All right, moving on to inverse trig functions. So before we do that, let's just remind ourselves a little bit about inverse functions. So remember, inverse functions are the of a function reverses the correspondence given. So if we have something like f of v equals u, right? So u is going to v. When you plug in u, you get v, or other way around, sorry. When you plug in v, you get u, right? Then the inverse function should be doing the exact opposite. It should be letting u go to v, right? So v should equal the inverse of u. So if we go back to what this actually means by x's and y's. So first, you may notice some of this stuff is a little different. If you want to go back, re-download this handout from Momentum, that would be probably the best. But continuing. So we see that we have, if y equals the inverse of x, right, then that means that, right, you flip it, so then f of y would equal x, right? In this case, x is going to be in the domain of, let's look at it, the inverse, right? And then y would be in the domain of f. Remember, domain just means what you're plugging into. What can you plug into? Which function? So since we're plugging x in this case into the inverse function, that's where the domain is. Since we're plugging y into the regular function, that's what that would be. Remember, the domain of our inverse is the range of the original and vice versa, right? The range of the inverse is the domain of the original. All right. So if we plug x into f and then plug it back into its inverse, we should end up just right back where we started, right? If you are plugging x into f, and it goes to y, right? When you plug it back into the inverse, it should end up back at the same place. And in this case, where's x getting plugged into originally? It's originally getting plugged into f, so it's in the domain of f. Likewise, if we take y, plug it into the inverse, and then plug it back into the original, we should get back to y. And what was the first thing we plugged y into? It was the inverse. Good. All right, if our point a comma b is on graph of f, right, then that means the point BA is on the inverse. Remember, if a point is on the graph, what we actually know is f of a equals b, which would mean that on the inverse, right, if we do the inverse, a equals the inverse of b, right? So what did we plug in? We plugged in b, which is why b is first, and then a. And because of this, you end up seeing that the graphs of both of these, the inverse and the original, are reflections of each other through the line y equals x. Right? Essentially, they will be reflections on each other, right? So, stuff like that. They look kind of like that. All right, let's talk about inverse sine. So, let's go back and remind ourselves, what is the first thing you have to do to have an inverse function? If you want an inverse function, the first thing you need is one-to-one, right? We have to have one-to-one correspondence if we're going to have inverse functions. So if we look at sine, is sine one-to-one? Not even a little bit, right? If you graph it, remember, one-to-one should pass the horizontal line test, right? Horizontal line test. It doesn't even a little bit pass, right? It crosses that graph an infinite amount of times, potentially. So, definitely doesn't work. However, we can adjust it to where it is one-to-one. So let's look at this. Where could this be one-to-one? Well, if we start at 0, right, we can see up until pi over 2, right, this is a single thing. This is a single part of the graph. However, we don't want to just end here because we know the graph goes below as well. So what would be this point? If this is pi over 2, we can see this would be negative pi over 2. And this is 1-to-1, right? So we want to make sure that when we are looking at sine, right, we want to make sure that we are only looking at x between pi over 2 and negative pi over 2. All right, so let's go to our notes. So inverse sine or a sine function, so we typically denote it as the prefix sine -1, or arc sine could also be the way we look at it. I think our textbook may be using the inverse sine, but I could very well be wrong. So just be prepared. These literally mean the exact same thing. There is no difference between them. So what this says is if we have that y equals sine of x, right, that means x would equal the inverse sine of y, or the arc sine of y. Now, what do we say about x? What do we know that x can, this only works for when x is what? It has to be between negative pi over 2 and pi over 2. So x has to be between negative pi over 2 and pi over 2 for this to work. So if it gives us an inverse sine, right, we automatically know that we're between negative pi over 2 and pi over 2 if it gives it to us. Likewise, what do you know about y? How high up does the y go? Well, that's pretty easy, right? That's just 1 and -1. Good. So remember, it is essential to choose y in the range between negative pi over 2 and pi over 2. Now notice it's the range of the inverse sine, right? So this is it's the domain of the original, but that means the inverse of the inverse. Good. Also, let's think about it using standard positioning, using those triangles, right? If we're at pi over 2 and negative pi over 2, what quadrants are we in? So we know this is 0. Pi over 2 is 90 degrees, so that's going to be right here. So this is as far as it can go. So what about negative pi over 2? Remember, negative goes in the opposite direction. So this would be negative pi over 2. So inverse sine is on the standard positioning is between the first quadrant and the fourth quadrant. So we are in the first and fourth quadrant if we are dealing with inverse sine. And then lastly, we know that if we plug in x, right, into sine and then into the inverse, we should end up with the exact same thing, right? This was the property of inverses. However, what do we know? This only works if x is what? X has to be between the negative pi over 2 and pi over 2 for that to work. Right? Otherwise, it's going to be a little off. And we'll see some examples. All right, if we also plug in y into the inverse and then back into sine, we should just end up with y only if what? What do you know about y? It's between -1 and +1. Good. So these, I'm telling you, these graphs are going to be very helpful for this stuff. This is how I do it, how I kind of can get my head around these kinds of things. If I know what the graphs look like, I can kind of go from there. All right, so let's look at this. So find the exact value of sine of pi over 4 plugging into the inverse. All right, so pi over 4, right? We know that's 45 degrees, so we're in the first quadrant, right? Remember, pi over 4, 45 degrees, we have to know 1 square root of 2. So what's the sine of this? We see that the sine of pi over 4 is 1 over the square root of 2, right? So then basically we're trying to figure out what is this, right? This is equal to what? So another way to write that, using sine, we could say sine of x equals 1 over square root of 2, right? Sine of what is 1 over square root of 2? And since we have inverse sine, we know we're only going to be between the first quadrant and the fourth quadrant, excuse me. Only the first and the fourth quadrant. So if it's positive, because they gave us the inverse, it has to be the first quadrant, right? So the sine is opposite over hypotenuse. We can do the Pythagorean theorem to tell us that 1 would be the adjacent, which means what is this angle? this is pi over 4. Yeah, we didn't actually have to do that. Because if you remember, right, we had this property. If it's between negative pi over 2 and positive pi over 2, which pi over 4 is, it just comes out to be itself, pi over 4. So we kind of did a lot of extra work. Haha. All right, let's take a look at this one. So if we have sine of the inverse sine of 1/2. So inverse sine is talking about the y values. Basically, can 1/2 be a y value? So if you want to use your property, right, can 1/2 be a y value for sine? Yeah, because remember, sine has to be, the y value has to be between -1 and +1. So if we're talking about a y value being 1/2, that's just going to be 1/2. Right? It's between -1 and +1. And that's back up here, right, for our property. Cool. Now, let's do this one. So we got inverse sine of pi, 2 pi over 3. So obviously, that's going to be 2/3 pi, right? No, it is not. So why is it not going to be that? Because, remember, we said that only works if it's between negative pi over 2 and positive pi over 2, which this is not, right? So we have to do what we already previously did for part A, which is why I wanted us to take a look at it anyway. All right, pi over 3, where are we? So, this is annoying. There we go. All right. So pi over 3, if you split up, so you know, right, this is 0, this is pi. So we split this up into thirds. This is where we are. We're going to be in the second quadrant, right? If you remember, if the bottom is 3, the reflexive angle is going to be 60 degrees. So that's 60 degrees. And if you don't know that, right, you can just convert that into degrees. So that would be 120 degrees. So what are we supposed to remember about 60 degrees? Well, across from it is square root of 3, adjacent is 1, hypotenuse is 2. What did we forget? Need to make sure to remember having that negative on the 1 because we're in the second quadrant. Good. All right. So what is the sine of this? Sine is going to be the square root of 3 over 2, right? So the sine, we said, was the square root of 3 over 2. So we're trying to figure out what is the inverse sine of the square root of 3 over 2. So what does that equal? So we can even put a question mark if we want. So remember, if we adjust it and rearrange it the way that it might make a little more sense to us, if we take the sine of what is equal to the square root of 3 over 2? Remember, since we have, it gave us inverse sine, what two quadrants do we have to be between? The first quadrant and the fourth quadrant, right? Since it's positive, we know we're in the first quadrant. Now, if this is all they gave us, right, if it's sine of x equals square root of 3 over 2, we would have two quadrants, right? What two quadrants would we have if this is what it actually gave us? We would be in the first and second quadrant, right, because it's both positive. But since we know we're only between pi over 2 and negative pi over 2, right, the only option in this case is going to be the first quadrant. So sine is square root of 3 over 2. We know 1 is going to be the adjacent by Pythagorean theorem, so we can see that this is just 60 degrees. And that's what we're trying to figure out, right? What is x? We've been doing this already, right? We're just kind of writing it a little differently now. So the value that we're looking for, if we talk about radians, is pi over 3. So we see, right, this actually is different, and that's why it's important to know the process as well. All right, let's do example number 2. Find the exact value of y if y equals the inverse sine of the tangent of 3 pi over 4. So this will be good to do. So 3 pi over 4, right? So again, if we have, this is pi, this is 0, right? If we split this up into fourths, it's going to look like this. So 3/4 is going to be right here. If you remember, the reflexive angle is going to be 45 degrees. Again, you can just do this, converting it to degrees and then seeing what you end up with. 45 is going to be 1 square root of 2. Remember, you need that negative on the 1. Good. So what do we get for the tangent of this angle, of this triangle? So we see the tangent is going to be just 1 over negative 1, which is negative 1. So y is the inverse sine of negative 1. Now, how are we going to figure out what y is? Well, we go back to our conversion. So if y is the inverse sine of 1, that means of negative 1, that means the sine of y is negative 1, right? So this should look very familiar, right? We've already solved these problems kind of a lot. So if we just graph our equation, right, negative 1, so we see we end up at negative 1 at 3 pi over 2. And if this was a regular equation where that's what they gave us, that would be perfect. However, for inverse sine, since they gave us inverse sine, what do we know we're actually between? Positive pi over 2 and negative pi over 2. So the question is, between these two values, where do we end up? We actually end up at negative pi over 2. So y is negative pi over 2. And you could have done it the way that we've always done it, right? So you could have done y equals 3 pi over 2 plus 2 pi n, right? But you need to make sure that your interval is between negative pi over 2 and pi over 2. So we can subtract 2 pi, right? Which would be 4 pi over 3. So if you subtract 4 pi over 3, we see that y equals negative pi over 2, which is the same thing we got. So you can kind of still do it the same way that we did it. The only trick is you had to know that we're between negative pi over 2 and pi over 2. All right, let's talk cosine. So once again, is cosine 1 to 1? If we're talking about inverse cosine, we need 1 to 1. Is cosine 1 to 1? Absolutely not. Not even close, right? Once again, it just goes on forever in both directions, right? So it infinitely crosses some of these. All right, so then what would be a good way if to get a one-to-one function? What would be a good range? Well, if we start here at 0, right? When do we go until we're not one-to-one anymore? So if you notice, if you go to 2 pi, well, that's too much. Doesn't pass the vertical line test. If we go to 3 pi over 2, again, doesn't pass the vertical line test. So actually, if we go to pi, that passes the vertical line test. So for cosine, right, we need to make sure that our x's are between 0 and pi. And do we see this? Do you see why? Cool. Also, yeah, so let's just write that down. So again, inverse cosine is gonna be the prefix of the cosine, cos negative 1, or arc cosine, which is just like that, right? So if we have y equals cosine of x, that means that x would equal the arc cosine of y, or the inverse cosine of y. And what do we say x had to be between? X has to be between 0 and pi. What about y? Well, the y values for cosine, how high up and down does it go? Just 1 and negative 1, right? So y just needs to be between negative 1 and positive 1. And we are including all of these values, right? That's totally okay. So again, just make sure, that's why I put this. It's super important. You need to know this for the test. So x, if it's in the range of the inverse function, needs to be between 0 and pi. And again, if you look at that, so where is 0 and pi if we're talking about the triangles, the standard position? We see that we're between 0 and pi, so we're actually in the first quadrant and the fourth quadrant, or second quadrant. Man, I keep messing that up. Anyway, so for arc cosine, for inverse cosine, it is different than inverse sine, right? Inverse cosine is 1 and 2. Inverse sine is 1 and 4. So we need to make sure that we understand that is different, right? Inverse cosine is going to be between 1 and 2. And then same thing, right? Just the property of inverses. If you plug in x into its cosine and then the inverse, you should end up with x, so long as x is in that range of 0 and pi, right? I guess if we wrote it correctly. That's what we would say. And then, of course, if you plug y into the inverse and then back into cosine, you should just end up with itself, so long as you're between 1 and negative 1. So let's find the expected value of cosine of the inverse cosine of negative 0.5. Well, if it's inverse cosine, this is the y value, right? So thinking about cosine, can y be between can y be negative 0.5, negative 1/2? Yeah, y can actually be between positive 1 and negative 1. So because it's in the range, right, we know that it's just negative 0.5, and we're done. Woo! All right, let's look at this one. So we got inverse cosine of the cosine of 3.14. Well, what do we know about 3.14? This is going to be the x value because we're plugging it into cosine. So remember, cosine, we said, had to be between 0 and pi. Is x between 0 and pi? Is 3.14 between 0 and pi? Yeah, because pi is 3.141 something, 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 right? So this should just be itself. Easy peasy. All right. And again, we're getting both of those answers from these properties that we had just discussed. All right. So here we go. We're going to plug something into sine and then plugging it into the inverse cosine. So obviously, this doesn't work, right? The same way the other ones. We have two different functions. We're actually going to have to walk through these steps and do them. So we have sine of negative pi over 6, right? Negative pi over 6. So negative pi over 6 is going to be in the fourth quadrant, right? We always start at the positive x and we go negative. We're going in that direction. Pi over 6 is the same as what degrees? 30 degrees. So this will be negative 30 degrees. What are the ratios we're supposed to remember? Across is 1, adjacent is square root of 3, and hypotenuse is 2. And then what do we need to remember? Make sure to put that negative on the 1 because we're in the fourth quadrant. Good. All right, so what is the sine of this triangle? The sine of this triangle is negative 1 over 2, right? So now we just plug that into our inverse cosine. All right, so sine of negative pi over 6 is negative 1/2, so then we just substitute that in. So now we try to figure out what is the inverse cosine of 1/2. So, right, if it equaled x, for instance, we can just do our natural thing, right, convert it into the more familiar one. Cosine of what is negative 1/2? So we can just do this as always. We have to do triangles for negative 1/2, so we ask ourselves, what quadrant are we in? Well, for cosine, we're either in the first quadrant or the fourth quadrant, right? Cosine is the x value, so we're either in the second or the third. However, since it told us that we were in cosine, right, told us inverse cosine, it can only be between the first and second, right? Which means we can't be in the third quadrant, excuse me. Cannot be in the third quadrant. So we have to be in the second quadrant. Does that make sense? Hopefully it does. If it doesn't, you can always shoot me a text or an email or whatever you need to do. But if we are given the square root, right, if we're given the inverse function, we know it has to be the second. If it doesn't, then it can be the second or the third. Here's an example. So I'm just going to put pause on here, but hopefully this little thing can help. So, and I know we might have some issues with this, but if I said that x squared equaled 9, what would x be? Well, you take the square root of both sides, and since we are taking the square root, we know that x is going to be plus or minus 3, right? It has two different options. But what if I said x equals the square root of 9? Now, I have given you square root. So you know, since I gave you square root, you only want the positive version, so then x equals positive 3, right? This is kind of the same way. If it just gave you cosine of x equals negative 1/2, we would be in two different quadrants. We absolutely would. Just like how if I gave you the square, we would have two different answers. However, since this only gave us the inverse, right, we know that we're in the second quadrant, just like how here we know we would want the positive. Hopefully that analogy makes a little bit of sense. Cool. So cosine, we know cosine is adjacent over opposite. So doing Pythagorean theorem, we see that we end up with the square root of 3. This should look familiar. We have a 60-degree angle, right? Which means that this is a 120-degree angle, which means that x has to equal 2 pi over 3. That's what we're looking for. All right. So now let's find the exact value of sine of the arc cosine of negative 2/3. So again, remember, arc cosine is the exact same thing as inverse cosine. So if it's negative 2/3, arc cosine, where are we? If it's the inverse cosine, we are between either the first quadrant or the second quadrant. So which one is negative 2/3? That's going to be the second quadrant, right? Because this is the x value. Cosine, when we think cosine, we think x. So if it's negative, right, we're here. So cosine, that's negative 2 over 3. So we need to figure out what the opposite is. So using the Pythagorean theorem, right, we get 3 squared minus negative 2 squared. So 9 minus 4 is 5. Make sure to take the square root. So we have the square root of 5. So what is the sine of this triangle, right? So essentially what we're saying is that this is an angle, right? So we can let this angle be the arc cosine of negative 2/3, right? Because that's what we're trying to find in this case. But then we want to find the sine of this angle. So we don't actually need to ever figure out what this angle is. If it's in this order, it actually ends up being super easy on us. We can just say, okay, now that we have this angle set up and this triangle set up, what's the sine? Sine's opposite over hypotenuse, which is the square root of 5 over 3, and we're done. Yeah, so if you're plugging in an arc or an inverse trig into a regular trig, that actually ends up being a little easier than the other way around, as we just saw, right, from this previous example. A little harder to do it the other way. Yeah, and again, we at no point needed to know what that angle was. All right, let's talk about tangent. So is tangent 1-to-1? Ultimately, no, but if you remember what our actual graph looks like, it's pretty 1-to-1 on its own, right, in this one period. So the question is, what is this one period? This one period is negative pi over 2 to pi over 2. Now, wait a minute, that sounds familiar, because that's arc sine, right? So arc tangent, so y equals tangent, this only works when x is between pi over 2 and negative pi over 2. And, right, since these are asymptotes, you can't equal either of those. And then what do we know for y? It's 1 and negative 1, right? Well, no, of course not. It goes on forever, right? So in this case, y can be anything, and that's totally okay. So what this ends up being, right, is that tangent, if you have arc sine, right, arc sine and arc tangent is between the first and the fourth. This is arc sine, inverse sine, and arc tangent, inverse tangent. And then cosine is between the first and second. Yeah, so between the first and fourth, you get arc sine, arc tangent. Between the first and second, you get arc cosine. And these are things you will definitely need to remember. All right, so inverse tangent. Again, we can just put inverse tangent like that, or arc tangent. So if we have y equals tangent of x, hopefully you figured this out by now. Basically, that means that x is going to be the inverse tangent of y, or the arc tangent of y. And what do we say the restriction for x was? X has to be between pi over 2 and negative pi over 2. And really, y just has to be a real number. Because it can be anything. All right. So, once again, If we plug x in, we can get x, so long as x is between negative pi over 2 and pi over 2. And if we plug in y, we should get y, right? In this case, for which y's? Actually, any real number, right? If y is real, since y can be any number. All right, so let's find this. So, tangent of inverse tangent of 1,000. So, inverse tangent is going into 1,000 is going into the inverse tangent, which means this is a y value. We said y values can be anything, right, on that tangent graph. So, answer is 1,000, and we're done. All right, if we have inverse tangent of tangent, all right, what pi over 4, taking tangent of that, and then taking inverse tangent of that, so we know this is going to be an x value. We said as long as we're between negative pi over 4 and pi over 4, we're fine. So, sorry, pi over 2 and negative pi over 2, so then this is just negative pi over 4, because it's between these two values. All right, part C. So we have arctangent of pi. So since pi is going into tangent, we know this is an x value. So is this a part of our system? No, it is not. Because remember, it has to be between negative pi over 2, pi over 2. All right, so we actually have to go through and do this problem. So tangent of pi. So if we are at pi, that's going to be right here. So what point could that be? There's many different answers. But we can say that this is negative 1 and 0, right? With a radius of 1. Going from here to here, that's 1. So if we drew a weird graph, right? Some people like drawing the weird triangles, which is fine, right? How far over did we go if this point is negative 1, 0? We went over negative 1, and we went up nothing, right? So when we do the Pythagorean theorem, we see that the hypotenuse is 1. And again, yeah, this doesn't make any sense because this is actually what it looks like. But this is just more for us to visualize it in our heads. So what do we see about the tangent? What is the tangent of this? So tangent of pi is just going to be 0, right? It's going to be 0 over... There we go. 0 over negative 1, which is just 0. All right. So now we need to find what is the arctangent of 0. So if we let arctangent be something, arctangent of 0 equal x, right? How can we change that around? That's the same as saying the tangent of x equals 0. And then that's easy, right? 0 is an easy number. If we graphed it, where does x end up at 0? 0. So our answer is just 0. Good. All right. So now that's pretty much it. So now we're just going to do some more examples and kind of see where all of these can take us. So we got secant of arctangent of 2/3. So arctangent. So this is a y value, right? And since it's not taking tangent of arctangent, that, it's not just going to end up being 2/3. But since we're doing arctangent, what values are arctangent between? Sorry, what quadrants are arctangent between? So arctangent can only be between the first quadrant and the fourth quadrant. That's super important to know. And since it's positive 2/3, we know we're in the first quadrant. So the opposite is 2. The adjacent is 3. If we can figure out what the hypotenuse is, right? 2 squared plus 3 squared. So 4 plus 9 is 13. Take the square root of everything. So we got positive square root of 13. So this is our angle. So now we just got to figure out what is the secant. So remember, I said when you have essentially when you're plugging in an inverse tangent into an actual or inverse trig into trig, makes it a whole lot easier. Essentially, we just make this alpha. So then what's the secant of alpha? Because we don't need to figure out actually what this angle is. What's the secant of this triangle? So secant is the reverse of cosine. So hypotenuse over adjacent. And that's our answer. right. Now we're getting a little trickier. So let's find the exact value of sine of arctangent of 1/2 minus arccosine of 4/5. So essentially what we can do is what we've been doing over here, right? So you can't just do 1/2 minus 4/5. You can't say tangent of 1/2. That's not what it is, right? This is arctangent, this is arccotangent. So what we can do is we can say, let's let this just be alpha, and let's let this be beta. So if we rewrote that, that would be sine of alpha minus beta. So now, is there an equation, is there a formula that we could use so that this could look a little nicer? We don't really know how to do alpha minus beta of sine, right? Because we don't know what those are. So is there another equation that we could use, maybe that we've talked about in the past, hint, hint, yes, the answer is yes, that we could figure this out? And yeah, this is actually the first thing that we talked about, right? This was the adding and subtracting of angles. So if you go back in your notes, this will be on one of the first equations we talked about in this section. We see that this ends up being the sine of alpha times the cosine of beta minus cosine of alpha times the sine of beta. So this is what we need to figure out. And this is doable. And again, this just comes from the formulas that I'll give you on the test. So here's another thing. So let's look at alpha. So we know alpha is equal to the arctangent of 1/2, right? So if we want to rewrite that, we could say the tangent of alpha is 1/2. So since it's positive, we know its tangent is going to be positive in the first quadrant and the third quadrant, right? That's when tangent is positive. However, since we started with arctangent, right, we know that we're just in the first quadrant. So we get, if this is our angle, 1/2. So the hypotenuse is just going to be the square root of 5. So sine of alpha is 1 over square root of 5. Cosine alpha is 2 over square root of 5. Now let's look at beta. So what do we know about beta? So it says that the arccosine of beta, or arccosine of 4/5, right? So beta is the arccosine of 4/5. So if we want to rearrange that, right, we see that cosine of beta equals 4/5. So just like we've always been doing, right? What quadrants are we going to be in? So for cosine, we're going to be in the first quadrant and the fourth quadrant. Because cosine, we think the x variable. However, it gave us arccosine. So arccosine can only be between the first and the second quadrants, which means we are in the first quadrant. Going through these steps is important because if this was all I gave you, you would actually have two different triangles. All right. There we go. So we got, oh, not yet. All right, so we got 4 over 5 for cosine, and we need to figure out what's the adjacent, right? So 25 minus 16, that's 9, so 3, right? Square root. Good. So again, we don't need to figure out what the angle is. We just need to figure out what is sine of beta. Sine of beta is 3/5. What's the cosine of beta? Well, we already had that. That was 4/5. Good. So if we just plug it into our equation, then we'll get what our answer is. So we had sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. So sine of alpha is 1 over square root of 5. Cosine of beta is 4/5. Cosine of alpha is 2 over square root of 5. Sine of beta is 3/5. When you multiply these together, you'll get 4 minus 6 over 5 times the square root of 5, which is just negative 2 over 5 square root of 5, which you can just leave it like that. All right, 2 more and then we're done. So what about this? We got 2, or sine of 2 arc cosine of negative 24 over 25. So again, this whole thing, we can just call it alpha. So this is the same as sine of 2 alpha. Now, right, 'cause you can't move the 2 inside. This is a whole angle, and this is just a number 2, right? Those are 2 very different things. So if we use our formulas, right, this is the double angle formula. So we know that that's 2 times the sine of alpha times the cosine of alpha. So we need to figure out, where's alpha? So if we have that alpha is the arc cosine of negative 24 over 25, then that means the cosine of alpha is negative 24 over 25. So how do you figure out what alpha is? We got to draw triangles. So when we think cosine, what letter do we think of? X. Since it's negative, we know that we're going to be in the first quadrant and the third quadrant. Hopefully all of y'all are yelling at me now, because you should know that one of those is not correct. Since we have the arc cosine, right, the third quadrant isn't correct. It has to be between the first and second. And again, this is good practice, because every other time, this has been the way we did it. So going through all of these steps that I'm doing, even if it's a little superfluous, right, even though it's a little extra, it's going to be helpful. All right, so we know that we have negative 24 over 25, right? Doing a simple calculation, you can see that the opposite is 7, which means that the sine of alpha is 7 over 25. So if we plug this in, all this stuff back into our equation, we get 2 times sine of alpha, which is 7 over 25, times cosine of alpha, which is negative 24 over 25. Again, notice, at no point did we ever figure out what alpha was. That was not important for this problem. When we multiply all those together, we end up with negative 336 over 625, and that's our answer. Last part. So there's 2 parts of this one question. All right. So again, we have tangent of 2 times the inverse tangent of 3/4. So since we know, okay, well that's annoying. That is super annoying. Okay. There we go. All right. We can say that that's alpha. So we have tangent of 2 alpha. So if we go back to our equations that were given, the double angle formula, that's going to be 2 times the tangent of alpha over 1 minus tangent squared of alpha. So now all we need to figure out was tangent, and we're done. So we said that alpha is going to be the inverse tangent of 3/4. So if we do our mumbo jumbo, make it a little easier for us to see, that means the tangent of alpha is 3/4. And that's actually all we need to do. We don't even need to graph it, because we just need to know that the tangent was 3/4. Yeah. Oh, cool. Yeah, we didn't even need to do anything extra. Perfect. All right, so that's just 2 times 3/4 over 1 minus 3/4 squared. So we see the top is going to be 6/4 over 1 minus 9/16. So if we subtract the bottom, we end up with positive 7/16, right? The way to divide fractions is by multiplying the reciprocal. We can cancel these out, right? 16 divided by 4 is 4. 4 divided by 4 is 1. And so what we end up with is 24 over 7, and we're done. All right, hopefully that all made sense. Again, if you have any questions, you can always email me or text me. Hope you all have a great day.